Hello everyone, welcome back to another session in the machine learning series. So we'll continue with the decision trees. The previous session you basically saw what is entropy and how basically entropy is calculated, right? Entropy is nothing but for each category, right? You just take minus probability of C into log 2. I think that is important, right? Log to the base 2 of probability of C. Today we look at information gain. So this basically is the main metric. Okay, so to put it simply, what basically information gain is, say how much of uncertainty in S was reduced, right? S is nothing but your data set. How much uncertainty in your data set was reduced after splitting the data set on attribute A, right? A could be any column, right? In whatever sample data set we saw outlook, we saw humidity, we saw columns like that, right? So what basically information gain will tell you is how much of uncertainty was reduced after your data set split on A, after your data set split on that particular column, right? That is because, so why we discussed entropy in the beginning was entropy is basically a measure of uncertainty in your data set. It basically tells you, it's basically nothing but a measure, right? So information gain will tell you how much of that uncertainty was reduced, right? The actual definition is, when you actually say mathematically define it, it's nothing but, it's basically a measure of difference in entropy, right? From before splitting to after splitting, right? It's basically a measure of difference in entropy from before to after the set S, after the data set S was split on attribute A. So that is basically what is information gain mathematically, right? Your entropy before, your entropy after. Okay. Now coming to the mathematical formula for information gain, I think now that you know the definition, right? So it's basically your entropy before and your entropy after, right? This is what is your information gain. So H of S is nothing but your entropy before, right? And the other formula which you see, the other formula of P of T into H of T, summation of P of T into H of T. So this is your entropy after you split on that particular split for a particular attribute, right? So when you actually look at the meaning of each one of this, so H of S is nothing but your entropy of your set S, T is nothing but your subset created by splitting that particular data set by A, right? P of T is nothing but your probability for that particular split, right? H of T is nothing but entropy of subset T, okay? Now basically what we'll do is we'll just basically, now that we know what is entropy, now we know what is information gain, right? Now that we know both of them, we'll basically calculate these metrics on that data set, data set which you basically we're discussing, right? So you basically have four columns. You have outlook, you have temperature, you have humidity, you have windy. So these are the four independent variables. And what is the dependent variable? What is the dependent variable which you're trying to predict is basically play, right? Play is basically the dependent variable which you're trying to predict. Play is a binary variable which is basically telling you whether you can play or you cannot play, right? So we'll basically look at calculating information gain on outlook on each of these columns. So basically we'll select the column for root node, whichever column has highest information gain, right? So we'll basically look at an example in calculating that. Okay. So this is outlook. So outlook basically has three unique values, right? So it is nothing but three unique values. So what basically you see in this particular step is you're just grouping by each one of those values, each one of those categorical values, outlook, right? So this yes no is nothing but your play column, right? So when outlook is sunny, this is the number of attributes in your play column. When outlook is overcast, this is the number of this is what is in your play column. When outlook is rainy, this is what is in your play column. And so this step is clear, right? So this is your column outlook. These are the three unique values in your column outlook, and this is its corresponding play column, right? So it's as simple as, say, you take a data set, you filter for column outlook. In outlook you filter for sunny, you get the first one, right? In outlook you select overcast, you get this. So this is from your play column, correct? And it's rainy, you get this. Okay. Now say let's go about calculating your information gain, overall information gain. The obvious first step is calculating your entropy when your outlook is sunny, right? So how do you calculate that? So from previous discussion, we know the probability of your entropy, right? Minus P of C into log 2 of P of C. So that is what is over here. MAFC P of C into log of P of C, right? So when it's overcast, since everything is 1, in overcast everything is yes, right? So that's why log of 1 becomes 0. right? So your entropy calculation when outlook is rainy is the same. So why do you see two numbers, minus 2 by 5, minus 3 by 5? It's nothing but you have two categories in your play column, right? So you have you have yes and a no. That's why it's basically minus 2 by 5 over here and minus 3 by 5. 2 by 5 is nothing but you have 2s by all of count of rows where it's equal to s. Count of rows where it is equal to s is 2, and divided by the total number of rows. Total number of rows is 5, right? So that is what is 2 by 5. 3 by 5 it's so that is what is no, right? Yeah, no, that is a count of no. It is a count of no, it's 2 by 5. 3 by 5 is nothing but your s, 1, 2, 3. You have 3 s's, that's why it's 3 by 5, right? So this is the first step. You basically calculate your entropy values for each one of your unique values in Outlook. So you calculate for sunny, you calculate for overcast, you calculate for rainy, right? So what is the next step is basically you just calculate your information, right? You basically calculate your weighted information, right? So what is this 5 by 14, right? You might be wondering this is weighted, right? What are you waiting for? Weighting, and what weight you're applying is, it's actually pretty straightforward, right? So this is so you have 14 rows. Your Outlook total number of row count in your Outlook is 14. In that sunny is 5. Sunny has 5 rows. Overcast is repeating in 4 rows, and rainy is in 5 rows. So that is what this weight is. Weight is nothing but 5 by 14 comes from there. Okay. 0.971 is whatever your entropy you've calculated. Right. So whatever entropy you've calculated, 0.971. This is where you get that from. So 0.971 is the same for both sunny as well as rainy. Overcast is obviously 0. Right. So you basically calculate now your information. Basically your information for Outlook, right? 0.963. I think this is, instead of information, you just take a weighted entropy, correct? Now your final information gain is nothing but entropy before, entropy after. So what is this? Your before is, say in the original data set, right, without any splitting. So if you consider play has 9 yes and 5 no, correct? So you basically apply the same logic over here as well. So maybe in this sheet, right, if you remember, so this is the original entropy calculation sheet. So in this, say, instead of total is equal to 100 over here, right? You took total is equal to 100. Take total as 14, right? Take total as 14 and yes as 9 and no as 5. And you calculate it in the same manner. Minus 9 by 14 into log 2 of 9 by 14 minus 5 by 14 into log 2 by 14. So whatever value you get, right? So that is your original entropy, correct? So that is what this particular value is, 0.94. So this is your weighted entropy. Whatever you get at 0.693, so that is what you create over here, right? So this is 0.693 is nothing but your weighted entropy. This is the difference. So this is what you calculate. This is the information gain for Outlook column. So in case some part of it you don't understand, maybe we can just check back, right? We can just maybe get back and have one more round at understanding this, one more iteration at understanding this. So this is the formula for information gain. Right, information gain is nothing but entropy before minus entropy after, correct? So probability of P of t into H of t, whatever you saw over there, right? So that is that was nothing but your weighted entropy. We calculated H of t for each of individual for each of these individual unique values, correct? We calculated for sunny, we calculated for overcast, we calculated for rainy. Probability of P of t is nothing but your number of rows, right? Number of rows to total number of rows. It has 5 rows for sunny, 5 rows for overcast, and remaining 4. I think rainy is 5, overcast is 4, sunny is 5. What would be the count, right? So that is what is P of t, right? Entropy. So formula is very simple, guys. Information gain, entropy before, entropy after. That's it. So that is what you get over here. So this is the value which you get, and you basically calculate your gain. You basically calculate information gain for one column, 0.294. In an exact same manner, you calculate gain for information gain for column windy. In the exact same manner, you calculate information gain for temperature and humidity. Right now, basically what you have is you have information gain for all of, you already have the calculated information gain for 4 columns. This is for Outlook, this is for windy, this is for temperature, this is for humidity, right? So you basically have 4 columns created. 4 columns information gain created. Right now, we basically what is the next step is you basically need to figure out which column will be a root node, and this is pretty straightforward because you basically choose that column, okay, that column with the highest information gain. As you can see, Outlook is a column with high information gain. So after this, how do you get those branches? You basically seen those branches, right? How do you get those branches? Branches is nothing but the number of unique values in that particular column. Okay, if it is a categorical variables, again, obviously. We see Outlook has 3 unique values: sunny, overcast, and rainy. So those becomes your 3 branches. Okay. So if this is for categorical, what do you do if it is continuous? If it continuous, what you basically do is you basically group it into certain ranges. 1 to 5 is 1, could be 1 to 5 or 5 to 10, right? So this is nothing but you create your ranges, and from that range you basically create your branches as well. You basically create a subsets from your continuous values, and from those subsets you basically create your branches. That is what the concept of branches. It's nothing but number of unique values in that particular column. Right? If it is a categorical vector, obviously it is the number of unique values. So this is how information gain is calculated, and it is used for calculating your nodes, right? Whether it's root node or any other particular node. Right? Even for as you build more nodes, as you make further splits, right? There's certain time where it will stop the processing. Right? It does not split further on a particular node. Correct? That node is basically called as leaf node. So how do you figure out a leaf node is? So as you can see in this example, right? So again, I'm just opening the same example. You see Outlook. Outlook is basically your sunny, overcast, and rain. In overcast, you see all rows are of a single value S. Right? So this basically means you cannot further split on. Right, so this is an example of a leaf node. So this is where you can make a decision. This is basically also called a decision node as well. Okay, guys. Then today we have discussed how using information gain to calculate information gain in each of these columns. In the next session, we'll basically look at other metrics. Okay, thank you.